sometimes when we're working with functions, we want to combine two functions or change a function in a certain way. And this lesson is kind of about how to do that and write it with function notation. So for this first page, we're starting out with two functions that are given, f of x and g of x. Our first problem says that we're going to add f of x and g of x together. Now, part of doing this is you have to recognize that that's not f times x and g times x or something that I need to actually add. That's referring to the functions. And you'll get used to it because you should see, when you see f of x, you should know it's not f times x, you should know it's a function. So I'm basically going to, when I see f of x, go and get f of x and write that down. So f of x is x squared minus 18x plus 80. And I'm also going to go and get g of x because I'm adding that on. So I'm going to add on x minus 10. Now, in general, it's a good idea to think about how parentheses would impact this. With adding, it doesn't because I don't have to change any signs. I don't have to distribute. But basically, I'm taking those two functions and adding them together. So combining like terms here, I have x squared. Negative 18 plus 1 is negative 17x. And then we have 80 minus 10 is 70. So this is a new function I've created by adding f of x to g of x, and that is my answer. The next one says f of x minus g of x, so I'm just going to take those same two functions. I have x squared minus 18x plus 80. And now I'm going to subtract g of x, which is x minus 10. So here I'm once again going to put them in parentheses, and here it does make a difference because I'm subtracting a binomial. So I'm going to change this to addition and change that to subtraction and addition like we've done many other times when we see that situation throughout the course. Then when I combine like terms, I have x squared, negative 18 minus 1 is negative 19x. That's not a plus sign, by the way, that's a 1x. And 80 plus 10 is 90. So that's the function created by doing f of x minus g of x. Down the page a little bit, we have f of x times g of x. So let me just move this back up a little bit so I can see them. So we're going to take the two functions and multiply them. Now I'm going to write it first off as I see it. So x squared minus 18x plus 80 times x minus 10. I'm multiplying my functions. Now I think it's always easier for me to have a binomial before a trinomial when I multiply. So I'm just going to use the commutative property to switch those two. That's optional. You could multiply it as it was at the first place. And now we're going to start distributing. So we see multiplication. So now this is the distributive property. We have x cubed minus 18x squared plus 80x. And then our second set of distributions, we have minus 10x squared plus 180x. And then lastly, minus 800. So when I combine like terms here, I'm going to have x cubed minus 28x squared plus 260x and then minus 800. So that's a cubic function that we got from multiplying a quadratic function with a linear function, which makes sense because we're multiplying an x squared by an x. The next one says division, so I'm going to take f of x and divide by g of x. Now, this is f of x divided by g of x. I know it's, not necessarily clear what's the best way to write it. If I was going to graph it, that would definitely work. But I do want to see if there's any possibility of factoring. So here, if I factor, I can factor the numerator. Numbers that add up to negative 18 and multiply to 80 are negative 10 and negative 8. So here I can cancel those x minus 10s out. Now, this new function is x minus 8. We're not really going to test it this unit, but one thing you do want to mention is it is the function x minus 8, except because we started out with a denominator of x minus 10, to keep the function equal to what the original was, we can't use a 10, even though 10 would be fine in x minus 8. So thinking about restrictions a little bit, but it's not really something you have to know in this course, but in the future it'll be important. On this page, we're going to start to talk about doing things to individual functions, not necessarily adding, multiplying, subtracting, or dividing. So we're going to start at what we know about manipulating functions, and we've done things both this year and in Algebra 1 where you did things like f of 3. So f of 3, we know, means plug in a 3 to all of the x's. So I would have -2 times 3 squared plus 3 times 3 plus 5. And I can't write the 5, so we're putting it down here. There's something on my screen that's in the way. So that idea, and then we'd simplify or we'd evaluate and we'd get one number. Now here on letter A, we're not plugging in a 3, we're plugging in a -x. And in general, whatever is in parentheses, we plug in for x. So writing this out, this would give me -2 times -x squared plus 3 times -x plus 5. And then we're going to have to simplify. So looking at this one, it can help to put 1s in here if you're having a little trouble. That definitely helps. Here, we're going to follow PEMDAS. So the first thing I'm going to do is this exponent part here. And since I do have multiplication, we can distribute our exponent, or I could write -1x times -1x. We're going to start to just distribute exponents over multiplication though as we head towards Unit 6. So that's going to give me -2. -1 times -1 is +1 x squared. Here, 3 times -1 is -3, so we get -3x plus 5. So to simplify this front part, -2 times 1 is just -2 x squared minus 3x plus 5. So this is the function that's created when we plug in -x for the x's in f of x. Notice it would have been kind of tempting, I know I just told you what to do, to cancel out these two negative signs, but this negative sign actually goes away in the squaring process, so it doesn't end up canceling out with the front -2. The next one's a little different. It says g of x, so I want to keep g of x. So here's g of x. I'm going to write it down. And then on the end, I'm going to tack on a -2. Now I'm going to use parentheses. Doesn't really matter in this one because we're not multiplying or we're not subtracting a binomial or anything like that. So now when I combine like terms, I get 3x minus 9. Notice we didn't plug in anything for x. We basically just tacked something onto the equation because it was outside of the g of x. The next one is a plug-in though, right? We have a 5x to plug in. So this one, I'm going to write down f of x. I have -2. For the x's, I'm plugging in 5x. So instead of x squared, directly where the x is, so I put a 5x there and then write squared. And then we have plus 3 times 5x plus 5. Here, we want to square both first, right? So I'm going to make this 25x squared. We'll write down the other stuff. I also, even though this is multiplication, since there's no exponents, I can do that at the same time, or no exponents in that term. And then we're just going to simplify one more time. So this is going to be -50x squared plus 15x plus 5. So that's our function with a 5x plugged in, our f of x function. The next one is a tack on. Do you see how we have a negative in the front of g of x? So basically we're going to do that. We're going to write a negative sign in the front of g of x. I'm going to put parentheses down to see if it matters. It does in this case. Even though we can't see the subtraction, basically the signs are going to change here because we're multiplying by -1. So this is -3x plus 7 is negative g of x. At the bottom of the page, we have a couple more. These can get a little trickier. Now, instead of plugging in a monomial, 5x or -x at the top for letter A, now we're plugging in a binomial, which just means we have to think about how does that impact our algebra. So I have f of x, -2. Now I'm plugging in x plus 3 and squaring it. Then we have 3 times x, so then that becomes x plus 3, and then plus 5. Here, because of that addition, addition changes a lot of things. in terms of how we do our arithmetic or, our algebra with simplifying, we cannot distribute the squared. We have to write it twice. And then from here, we're going to have to do that distribution, and we're going to pick which one we do first. I can do this distribution here because there's nothing else in that section. Now, it's really nice. I could multiply the -2 in, but I also think if I can find the pattern here and just write down what it is, if I multiply this out, I get x squared. I get a 3x and a 3x, which is a 6x. So I'm doing two distributions at the same time just so I don't have to write this so many times. And then 3 times 3 is 9. I'm going to combine the 9 and 5 together to get 14. So we have -2x squared minus 12x minus 18 plus 3x plus 14. And then we have one last combining like terms. So that gives me -9x and then -4. So those ones where we have the binomial squared are definitely the longest problems in terms of how much we have to do with them. The last one is a tack-on, right? We're putting 3 in front of the function, and in this case, it's f of x. So let me just get my pen. We are doing 3 times f of x, which is -2x squared plus 3x plus 5. Then we distribute because it's just a single term times a trinomial, so -6x squared plus 9x plus 15 is the final answer for that one.